Okay, so welcome back. Okay, in this last part of the basic properties of duality, we look at this notion of dual certificates. Okay, somehow duals are good as certificates for proving optimality. What does this mean? Okay, so here is the problem, and suppose someone comes to us and gives us a solution X and says, okay, this could be a program, this could be a person, that they come up and say, okay, I'm giving you X star, trust me, it's the optimal solution. Okay, and the question is, do we trust them? How do we trust them? All right. Well, one part is simple. We can check if X star is feasible. If it's not feasible, we can say, go away. Don't bother me with an infeasible solution. I can check that. Okay, that's easy. Now, how do we check if it's optimal? So we know that the person has given us X star and claims that Z star is the best value that you can get. Okay, we know that, but how do we know that some other X star 1 doesn't give us a better value of Z star 1 and still feasible? How do we know that? We cannot do better. Okay, it's an age-old question. If someone gives you some price for your car, how do you know that you can't do better? Okay, it's the same with linear programs. Someone gives you a solution and says this gets you a value of 10. How do you know that you cannot do 11 or 12 or 13? And the answer, in the light of this discussion, comes from the dual. Okay, now suppose instead of giving us X star, the person actually gives us both X, okay, a primal feasible solution and a dual feasible solution. Suppose the person says, here, take a primal solution and take a dual solution. Take both. Okay, so the question is, and the person claims, well, okay, X star is claimed to be the primal optimal, and Y star is claimed to be the dual optimal. How do we convince ourselves? Very simple. We check feasibility of X using the primal problem. Okay, now if we have the data from the primal problem, A, B, and C vectors, we can use this and we can construct the data for the dual problem, A transpose C and B. Okay, that's the data for the dual problem, and we can use that data to check feasibility of Y. Okay, if let me call them Y star and X star, so that we can check feasibility for Y star. The final thing you have to check is that their objective values coincide. B transpose Y star equals C transpose X star. You have to check that they are the same. Now, using these two, then, a given primal solution and a given dual solution, you can easily check without having to resolve simplex. You can easily check that the primal and the dual are optimal for each other, and together they certify the optimality of each other. Okay, so the primal certifies the dual's optimality, the dual certifies the primal's optimality. It's almost like magic, but it's very interesting to see that this happens. Okay, let's go through an example and see how that happens. Okay, so here is an example. Okay, I claim that Z equals 12 is the optimal solution, and I say that X1 equals 2 and X2 equals 2 is the optimal solution. Okay, so I can certainly check that this is feasible. Go through every constraint and check. So in this constraint, you get minus 2 times 2 plus 2, which is less than equal to minus 2. So this constraint is correct. X2 less than equal to 4, correct. X1 minus 2, X2 less than equal to minus 2, correct. X1 less than equal to 4, correct. X1, X2 greater than equal to 0, correct. So you can check every solution. How do we know we can't do better? Okay, someone gives you a dual feasible solution, say this one. Okay, now you form the dual problem, so you just take this problem and automatically form this dual. Okay, check feasibility. So for example, all right, and so you check solution by solution. So you say minus 2y1 plus y3 plus y4 greater than equal to 1, check. Y1 plus y2 minus 2y3 plus y4 greater than equal to 2, check. Left hand side comes out to be 3, and check. Okay, so you check all the constraints and you look at the objective you get from this side. The objective you get from this side is 4 times 2 plus 4, which is 12. Okay, so therefore the primal also gives you an objective of 12, and the dual solution I gave you also gives you an objective of 12, which immediately tells me that this is primal optimal, and it also tells me that this is dual optimal. Okay, so you can use the primal and the dual to certify each other.